This video will take you through the 6.3 lesson, Area of a Circle, page 4. We'll start with problem number 11. A radio station broadcasts a signal over an area with a radius of 50 miles. The station can relay the signal and broadcast over an area with a radius of 75 miles. How much greater is the area of the broadcast region when the signal is relayed? Round your answer to the nearest square mile. And so we're going to be finding the area of essentially two circles. The first one is the area of a circle with a radius of 50. And as we did with the previous pages, we're primarily relying on area equals pi r squared. So plug in, they give us the radius. So the area is 2,500 pi square miles. And in just a minute, I will round this all out because I want to eventually get a rounded answer to the nearest square mile. For now, I'm going to leave it in terms of pi. I'm going to now go to the larger circle, which has a radius of 75. And 75 squared is 5,625 pi miles squared. And now with my calculator, to figure out how much larger it is, I'm going to find the difference. And so I'm going to figure out what is 5,625 times pi minus 2,500 times pi. So we have 5,625 pi minus 2,500 pi. We're rounding to the nearest whole number, so that would be 9,817 square miles. You might also want to, as you're entering this in, if you're having difficulty figuring out what this is, on your calculator, you're timesing by pi or 3.14 if that's what your teacher prefers, and writing that number down, and then also doing the same thing for the smaller circle and writing it down. If you have the ability to type it in all at once, you could also try that, as I just did. Let's go to number 12. Determine the area of the shaded region in each of the following figures. On 12a, I notice I have a square, and I want to find the shaded region that's between the circle and the square. And I notice that I need to find the length of a side of this square. I notice the radius is 5, which means that the diameter is double, which is 10, which is also the side length of the square. So the area of the square is side squared, which is 100, and this is in inches squared. Let's find the area of the circle now. So for the circle, I'm going to be relying on the radius. So now I'm going to use pi r squared. And that is 25 pi inches squared. I'm going to round to the nearest hundredth. So 25 pi nearest hundredth is 78.54. And I'm going to find then the difference between these. So 100 minus 78.54 equals 21.46. Let's look at B. B has now 4 circles and a strange shaded region in the middle. It's lacking a square, but in fact, question A helps you answer question B. So if I consider one of these circles and think about it in terms of the question I just answered in A, there is essentially the outline of the square, and here are those shaded regions that I did on question A. And I actually notice that those match up with the shaded regions that are in the middle. That these four blue ones, you could reform them or realign them to make this shaded gray region in the middle. And so I'm actually going to solve this problem the same way I solved A. So I'm going to find the area of the square, of this outlined square here that was not really there, but I'm realizing that I need to do that. And so if the radius is 1, I know the diameter of the circle, or the side of the square, is 2 inches. So the area of the square is 4 inches. Next, I want to find the area of one of these circles. One squared is 1, and so the area is pi inches squared. And if I find the difference between these two shapes, the square and the circle, I should be finding this blue region, which should be equal or the same as the gray region. And so I need to figure out what is 4 minus pi. Again, if your teacher prefers 3.14, then your answer might be just off a bit. So at least on how I typed it in the value that I'm using for pi, I got 0.86 inches squared. All right, let's go to number 13. These four squares have sides of 2r, so each one of these is 2r. Which figure has the largest shaded region? So we're going to find, in the first example, we need to find the area of the circle. And so the radius of this circle would be just r. So area equals pi r squared. In fact, that's the area of the first shaded region. Let's look at the area of the second. So in this case, area equals pi r squared. Area equals pi, and I notice that the radius is actually 2r in this case. And so this is area equals pi times 2r, because squaring means to multiply it times itself. And the area would be 4r squared pi. And the other thing I need to take into consideration, this is not a full circle. It's part of a circle, and so I'm going to take that area and multiply it by a quarter. And when I simplify that out, I actually get pi r squared again, which is what I got on the first shape. So in fact, these areas are equal. The next shape, in fact, looks just like the first one. It's just that they kind of oriented the two semicircles in a different manner, so I would say that the area of this one is also pi r squared. And the last one, actually all four of those parts, if you were to kind of cut them out and move them around, you'd have the area of what you had in the first shape. And so the question was, which figure has the largest shaded region? All of the shaded regions are equal. Let's go to the last question for this page, number 14. How does the area of a circle change as the radius is multiplied by a factor of n, where n is a whole number? Well, let's consider we have area of a circle is pi r squared, and we'll maybe first attempt this by looking at it with numbers, and then we'll consider it with a variable. So for example, if we look at a radius of, let's say, 3, the area would be 9 pi. And what we're going to do is, let's use a scale factor of 2. So now when I do the area for my new circle, I'm going to be using a radius of 6. So following order of operations, I'll first multiply, then I'll square. And I think we saw this in some of the previous problems and maybe even some of the lessons at the start of this module, that I noticed that my scale factor is actually squared, that I doubled the radius, that was my scale factor, but now in comparing the areas, I actually quadrupled them. So let's now look at this with n. If I start with an area of pi r squared, and then I consider a circle where the radius is multiplied by n, and everything here is multiplication. And so these grouping symbols really aren't doing anything. And I can multiply in any order I'd like, so I'll multiply the r's, which is r squared. I'll multiply the n's, which is n squared. And I can see that the comparison of my areas is that the area was multiplied by the scale factor n squared.